Hello everyone, this is 9.3 Solving Quadratic Equations by Graphing. So today we're actually going to learn how you can solve an equation like this, not by factoring, but by using Desmos and looking at the graph. You're also going to be expected to then draw a sketch of the graph, including what the zeros are, which is your solutions, which is where the graph crosses the x-axis. So before we start, we're going to warm up by just using factoring and recalling what we learned from Unit 8, because this is still important. Although you can solve it using Desmos, the questions on the air test might ask you questions regarding like how it would be simplified or what it would look like being factored. So you still need to know how to factor, but we can use Desmos to check our answers. So for this one, this is a trinomial. You would factor it using two groups like that. And then you would put x in the first spot. And then you ask yourself, what are factors of 5 that add to -6? Well, the only factors of 5 are 5 and 1. So you choose 5 and 1. And the signs, in order to create -6, you would do both of them negative. So then the solutions for this would be x equals 5 and x equals 1. For number 2, this is not the same thing as trinomial factoring, but it is a difference of squares, where the square root of 4x squared is 2x, and the square root of 9 is 3. So we would write 2x plus 3 times 2x minus 3. And then our solutions would be, you would subtract the 3 and divide by 2. So x equals -3 over 2, and x equals +3 over 2. Right, finding the zeros, so solving the equations and finding the zeros is the same thing. What we're doing here is we're just figuring out what are the x values where the y is 0, which is also asking you for the x-intercepts. So those are all mean the same thing. So here we would set it equal to 0 and factor it. This is kind of like number 1. So you put x in the first spot. And then factors of 36 that add to 5, you've got 1 and 36 obviously isn't going to work. 2 and 18, no. 3 and 12, no. 4 and what's 36 divided by 4? And 9. Okay, 4 and 9, that's going to work. So where did my cursor go? Oh. Okay, so 4 and 9. Sorry, my cursor. Oh boy. Let's see here. So you do -4 and then +9. So your answers would be 4 and -9. Okay. Now we're going to solve using Desmos. So it says to include a quick sketch of the graph, identifying the vertex and all intercepts. So if you want to follow along with me, you can. We're just going to open up the Desmos graphing calculator. So you would go to desmos.com, click on graphing calculator. And the first example is x squared minus 2x equals 3. Now what we want to do first, though, is subtract the 3 over, like that. Because it was equals 3, but that would give you that, because that's just giving you the solution. So that still works to give you the solution, but if you want to graph it, you have to subtract the 3 over. And I don't think you would say equals 0. You would just maybe put y equals in front or just leave it like that. So here, if you just click on the y-intercepts, those, or the x-intercepts, those give you the solutions. So here, our solutions are the x values, so negative of the x-intercept, so -1 and 3. So here we would just say x equals -1, x equals 3. If you factored it, you would get the same thing. Okay, and then a quick sketch of the graph. I don't know why I keep losing my pen. There it is. Okay, so I'm going to draw an x and y axis. For Elastic, you will actually be giving a graph to work with. Okay, I can't see where my pen is drawing. I'm just going to use this. So we would mark our intercept at -1 and 3. And then the y-intercept, let's see what the y-intercept was. Well, if you plug in 0 for x, you're going to get -3 for y. So the y-intercept was -3. And then the vertex is at 1, -4. So 1, -4 is your vertex. And then the graph goes like this, passes through the y-intercept, through the vertex, and back up. Okay. For this one, once again, we want to get this number over onto the other side. So we would do -x squared plus 2x minus 1. Type it into Desmos. So -x squared plus 2x equals 1. Oh, sorry, I meant minus 1. All right, so this is an example where it will just touch the graph at one point. So there's only one solution for this. Because if you factored this, it would end up being like, so if you flipped all the signs and called it x squared minus 2x plus 1, this is a perfect square trinomial, and it could be factored as x minus 1 quantity squared. So the solutions are just 1 and 1. So that's where this comes from. Okay, so our solution is at 1, and then we would just plot the y-intercept at -1. And the vertex is the same thing as the solution. So -1, so +1 here, -1, put a point there, put a point there. All right, and then this one is the same, so we would subtract the 4x over, and then plus 7, and let's graph that. X squared minus 4x plus 7. X squared minus 4x plus 7. Okay, so something interesting happens here. Are there solutions? Remember, solutions are where it crosses the x-axis. So for this one, there are actually no solutions because it never touches the x-axis. The vertex is above the x-axis and the parabola opens up. But we can still graph it. We can still plot the vertex and we can still plot the y-intercept. So we've got 2, 3, and 7. Oh, we should probably graph more of the first and second quadrant. So 1, 2, 3, 4, 5, 6, 7. There's our y-intercept, and then 2, 3 is the vertex. All right, so you get the idea. Let's go on to the next page. You can do the other examples if you want. So for this part just explains what we talked about. Quadratic equation has two solutions if the graph of its related function has two x-intercepts. It has one solution if it has one x-intercept, and it has no solutions, no real solutions, if the graph of its related function has no x-intercepts. All right, so let's do a word problem that we can use with our calculator, or our Desmos, rather. An athlete throws a shot put with an initial vertical velocity of 40 feet per second. So the equation would look like h equals -16t squared plus 40t, and then, oh, I always forget to add in this part. The initial height is 6.5. That's how tall he is, maybe. So plus 6.5. Use the equation to find the time that the shot put is in the air. Okay, so what we're going to do is we're going to take this and put it into Desmos. So we had -16. We're going to use x squared though, plus 40t, plus 6.5. Okay, and it says so there's the initial height, that's the y-intercept, and then it goes up goes up really far, and comes back down after 2.653 seconds. So oh goodness, 2.356 seconds. That's the time that it's in the air. And then what is the shot put's maximum height? So draw a diagram. Well, it looked like this. The diagram started here, went up really high, came back down after 2.356 seconds, and then this would be the maximum height. And by looking at this, we can zoom out and just click on that top part and it'll show you the maximum height. So the maximum height is at 31.5 feet after 1.25 seconds. So this would be 31.5 feet. Okay, number 2, the height of a soccer ball after it is kicked can be modeled by the graph of the function, where x is the horizontal distance that the ball travels. The ball is not touched, so it kind of looks like this. The y-intercept would be 0 because there's no c value. Goes up, comes back down after how many seconds? The ball is not touched and it lands on the ground. Find the distance that the ball was kicked. So that's asking for the x. So it's asking to find what this point is when it lands back on the ground. And it's not seconds now, it's just a horizontal distance is being represented by x. So let's put it into Desmos. So we've got the equation negative 0.04x squared plus 1.2x. So this is what it looks like, and its maximum is 15,9. So that means the maximum height is 9 feet after 15 feet across, but it's not asking for the maximum. It's actually asking for this value. What's the horizontal distance that it travels? So that would be 30. 30 feet. All right, so that is the end of this lesson that focused on solving quadratic equations using the Desmos graphing calculator. Hope you guys have a great day.